Good morning, Algebra 1, and welcome back after a long hiatus of math. It's been almost a week since our last class. So we are going to do one of the most fun parts of algebra. Just kidding, it's not that fun. But anyway, we are going to start going backwards and writing things from standard form and turning them into factored form. And we're going to learn a sort of strategy to help us do that. So the first thing I want to do is focus on how to go from, how to use a diagram or distributing to show that the factored form actually gets us the distributed form. So I'm going to go ahead and I'm just going to show an area diagram super quick for one of them. Hopefully we can extend it to all of them. And we'll look at how to distribute properly to get the actual standard form. So we have our area diagram for our first one. And we see that x plus 2 by an x by 4 rectangle has an area with 4 different parts. There's an x squared, a 4x, a 2x, and an 8. Kind of like that Punnett square math. Then that 4x and that 2x combine to give us 6 total x's. So that's why this turns into this. They're equivalent expressions. Then down here, I can distribute. I get x times x is x squared. And then really I should do 10x first and then 4x second. Then x times 10 gets me 10x. 4 times x gets me 4x. And then 4 times 10 gets me 40. And then again I combine my like terms to get x squared plus 14x plus 40. And I can do the same exact thing with the next ones. Noticing here when I have two negatives, my linear term becomes negative and my constant term becomes positive because a negative 5 and a negative 1 makes positive 5. And same story down here. When I have two negatives, they make a positive y term. So I want you to observe the pairs of expressions we've got. We've got this first one in black. We've got the second one, which I will, I guess, make blue. We've got the third one in green. And we've got the fourth one in purple. So I want you to observe the pairs of expression that involve the product of two sums or the sum or two differences. So we have a plus and a plus, or a minus and a minus. And I want you to see how is each expression in factored form related to the equivalent expression in standard form. Do you notice anything about the relationship between the numbers you start with and the numbers that you end with? Like what happens there? The thing to really notice here is that the x term is the sum of the two numbers that get added to x. So up here in the black problem, I have x plus 2 and x plus 4. And when I area diagrammed it out or distributed, I ended up with a plus 6x because I had a 2x and I had a 4x. So whatever those added together to get, it becomes my x term. And whatever my two terms were multiplied together, they multiply to get me my constant term, or my plus 8. So the goal is really seeing that whatever my two numbers are after the x get multiplied to get my last number, and whatever they sum to gets me my x term, my second number. So we can see that's true for all of these. So plus 4 and plus 10 add to get me 14. And then plus 4 and plus 10 multiply to get me 40. And even the negatives work the same way. The minus 5 and the minus 1 multiply to get positive 5. And if you add negative 5 to negative 1, you get a negative 6. So if you have a negative x term, you're going to be dealing with at least some subtraction here. Okay? So we're going to try a couple of these. And the really important part is we're going to try to do is we're going to break it down to steps. So we're going to look at just part A for now. So we're going to try to find two numbers that satisfy the requirements. If you get stuck, try listing all the factors of the first number. So we're going to find two numbers that multiply to get 20 and add to get 9. So I'm going to try to list all the numbers that multiply to get 20. So let's see. So I'll do blank times blank equals 20. So I'm going to say, let's see, so I know that 5 times 4 equals 20. And I know that 1 times 20 equals 20. And I know that 2 times 10 equals 20. And that might be it. Well, you could do decimals, but we're not going to right now. So now I want to see which of these pairs of numbers adds or sums to 9. And that winning pair is, hopefully you saw it when I did it, but it's this one right here. That one sums to 9 because 5 plus 4 is 9. So now I know that when I factor this, it's going to be x plus 4 times x plus 5. Because if I distribute this out, I'd get x squared, then I'd get a 5x, and then I'd get a 4x, and then I get 5 times 4 is 20. So that is actually going to go down here, use them to factor or write in factored form, x squared plus 9x plus 20. So again, multiplying 20, I'm going to put that in purple, and that's going to be that plus 20 right here in purple. And then I'm going to put my add to get me 9 in, not red, on this beautiful blue right there, and that plus 9x is going to go in that pretty blue as well. So I want you to try coming up with two numbers that multiply to get 17 and add to get 18. So first, again, you want to try what times what gets me 17, and then what pair adds to get me 18. So in this case, I can only think of one pair. 1 times 17 gives me 17. And it turns out that 1 plus 17 equals 18 as well. So they're only one different. So that kind of clues me in right there that I'm dealing with a 1. So that means my factor form is going to be x plus 1 times x plus 17. And that would get me x squared plus 18x plus 17. Because our goal is really to be writing something that looks like this in factored form. Okay? So find two numbers again that multiply to 11 and add to negative 12. And we're going to use those numbers to factor this right here, x squared minus 12x plus 11. So when I factor that, and I'm going to check, I can check my answers when I'm done by multiplying them out and seeing if I get this. So let's see, what two numbers multiply to get to 11? Well, again, there's not too much that multiplies to get to 11. I'm thinking, all right, well, I know 1 times 11 equals 11. So those are my two numbers. But they don't add to get me negative 12. But what else multiplies to get 11? I could also say, or negative 1 times negative 11 is 11. And negative 1 plus negative 11 gives me negative 12. So this really is not my winning pair. My winning pair is negative 1 and negative 11, which is going to make my factored form x minus 1 and x minus 11. And that's going to get me my answer. Now I know what you're thinking. This seems a bit complicated. Yeah, it takes a lot of getting used to, but hopefully this is a little bit manageable. You got today and tomorrow to really get good at parts of this. It does feel frustrating sometimes. It's a lot to get used to. It's a lot to do distance, but don't worry, we're in the home stretch. If this is the last thing we learn this year, and this is all we do for the rest of the year, like truly we've still done a pretty good job. So let's just keep going. So find two numbers that multiply to 36 and add to get to negative 20. And again, that's going to help us factor our x squared minus 20x plus 36. Because that multiply term, that end piece, tells me my last two numbers. So there's a lot of numbers that multiply to get 36. That's a big one. That's always a fun one to do. So that's for the end. So now I want to think, all right, let's see. I know 6 times 6 is 36. And I know that 9 times 4 is 36. And I know that it's always easier to start with lower numbers, like 1. So 1 times what is 36? 1 times 36 is 36. And I know that, let's see, 2. 2 times 18 is 36. So what about 3? 3 times 12 is 36. So you have 4 times 9 was 36. 5 times nothing, so it'd be 7.2. And then 6 times 6. So once I've reached my factor again, I know I'm all set. So I have my 5 nice factor pairs. Now which one of these adds to get me negative 20? 6 and 6 is 12. 9 and 4 is 13. 1 and 36 is 30. These are all positives. So here's what I have to realize, that I could also pick all these negative numbers. So I like this pair, but I need to make it negative. So I need to make it negative 2 times negative 18 gets me 36. So that means my factored form is going to be x minus 2, x minus 18. I'm going to go ahead and check my answers to see if that actually equals this right here. Okay, so I'm going to do, let's see, so x squared, I'll get x squared, and then x times negative 18 is negative 18x. Negative 2 times x is negative 2x. And then negative 2 times negative 18 is positive 36. And then that will combine to get me x squared minus 20x plus 36. And I have just factored this beautiful little quadratic expression. So that's a good place to start. We could try a couple more. What I'm going to do is I'm just going to sort of project the next part of it. I'll have you pause it for as long as you want. I don't know how long the live's going to do for this. I don't know how much they're going to do of it, if they're going to do any of it. But I'm going to show you these problems that you can do. Go back and forth from factored form to standard form. Really just get used to the idea of going from one to the other, the connection between the two. And then we'll do some quick, I'll show you the answers real quick, and I'll just go for the summary. Ask me questions on it if you have any. And yeah, give it a pause. Try these, or some of them. Try a few. Try all if you want to. And then I'll show the answers.